Hello everyone, welcome back to the channel. In this video, we'll be talking about state graph, the concept of state graph in LangChain. So before we start, we have already seen we have already seen an introduction to LangGraph in the previous video and what is a simple graph. And we also saw a small use case, using a simple graph in LangGraph, right, to create a workflow. Right, so this is the playlist where I'll be putting all the videos, all the different aspects of LangGraph with some sample code, sample project. So this playlist is going to have all the basics to advanced concept of LangGraph, right? So now in this video today we'll be talking about state graph, right? In the last video we talked about a simple graph. So a state graph is a graph where nodes represent functions and edges, right? And edges define the execution flow between them, correct? So basically it's a graph, right? It's a graph, just like a simple graph, but here we have the concept of state, right? Here also we have the nodes, which are the functions, and then edges define the execution flow between them, right? Then here the additional thing is that in the state graph, we also have the concept of state. So the state graph helps maintain shared state, making it ideal for structured workflows, right? So if we have to maintain a state across different nodes, so what is a state? A state is basically nothing but if we want to keep the flow of a variable or an input throughout the workflow, throughout the various nodes, then state is very useful, right? So each node performs a computation and updates the shared state, right? So the shared state is basically shared across different nodes, all the nodes in the workflow. The graph flows. The graph follows a defined execution flow, ensuring logical processing of tasks. Right. So the state represents the current data at any point in the workflow. It can be defined using either PyDentic's base model, either PyDentic's base model. This is very important, or using TypedDict. Right. So there are two ways of implementing or using state in state graph. Either by we can either use the PyDentic or we can go with the TypedDict, right? So now we will also see a code, and then we'll try to understand how the state is flowing across various different nodes, right? So before moving on to the further explanation about these two diagrams, let's see the code quickly, right? So here, first of all, we start off with importing the state graph from langgraph.graph, and we also import start and we have already seen what is a start and in the previous video. If you want to check about that, refer to the previous video in this playlist. Then first of all, we'll start off with implementing using base model from Pydantic, right? So first of all, we define the state using base model. We import base model from Pydantic, and then we create a class where we basically define the states, right? So we have a few variables here like num1, num2. Then there's a result variable which is some result, and then again the final result variable is final result, right? All these are floating type. So here what we are trying to do is we'll be giving two numbers as input, number one and number two. Then we'll add these two numbers, and then we finally multiply this number by a constant. Here we are multiplying by 2. So this is a simple code, but the core idea is to understand how the state or how the variables flow across various nodes and how state enable that, right? So after we have defined the state using base model, then we define the node functions, right? So the first function is add numbers, where this one takes the state here as input. Then we say state dot sum result is equal to state dot num1 plus state dot num2, right? So these two numbers num1 and num2 are present in the state, right? In the state graph, right? And then this sum result is also present in the state. So we are able to use this from one node to the other node, because these are available in the state, right? Then we have another node which is the multiply result. Here again we are using the math state here which we defined, and then here we are saying state dot final result is equal to state dot sum result. If you see in this function, we are nowhere defining the sum result variable, right? But we are able to use it because this sum result is present in the state, and this has this particular value after adding these two numbers, right? So we are saying state dot sum result into 2, and then we are saying return state. Okay, now we initialize and build the graph, right? So we say graph is equal to state graph and then math state. We are taking the state here while defining the or building the graph. and then we start adding the nodes. So first of all, we add this add numbers node, and then we add the multiply result node, and then we define the edges, or we add the edges, right? The edges are nothing but these, the edges basically, they join the various nodes, right? They join the execution flow, or they create the execution flow, right? Basically by joining different nodes, right? So first of all, we start off with saying graph dot add edge start add. So after start we have add, right? And then the second edge is between add and multiply, right? And the third edge is between multiply and end. We'll see the picture of this once we are done with the coding part. So then we compile this graph, right, by giving graph.compile, right? And we give the variable app here. Now here we give the initial states, or the initial values of the variables, right, inside the math state class, right? Num1, num2, 5 and 3, right? And then final state, to get the final state, we basically invoke it, app dot invoke. We invoke the graph, app dot invoke initial state. So this takes these variables, and then it passes these numbers, or these values 5 and 3, to the first function first of all, right? And then the addition happens, and the result is saved in sum underscore result, and then the state is returned. After this is done, then this particular result, or the sum result, is passed here via using the state here. So in this one, what we are doing is we are multiplying the sum result by 2 to get the final result, right? And then we again return the state. So here, if we see the final result here is the num1 was 5, num2 is 3. So we get everything here in the state, whatever is there in the state, right? Then some result is 8 and final result is 16, correct? Perfect. So now we'll implement the same thing using TypedDict. So same implementation, nothing changes. It's just that there are two different concepts, two different examples. So we will see this. So first of all, we import from typing import TypedDict, and then we again create the math state class using this TypedDict. We have again the same variables num1, num2, some result, final result, right? And then here we are using it like this, we are saying some state, some result is equal to state num1 plus num2, same thing. Then we are returning the state. Then again we are multiplying the sum result by 2 and storing the result in final result, right? Then again we create the graph, then we add the nodes, add numbers, multiply result, then we add the edges with start end, and then the edge between add and multiply, and then the edge between multiply and end. Okay, then we again compile it, then the final result is 16. So if we just want to visualize this, so this looks like this, right? The start and then add, this is the first node, and this is the edge. Then again between add and multiply we have an edge, and then once we get the final result, we reach the end here, right? And then again there is an edge between multiply and end. This is the overall flow here. Now let's go back to this diagram just to visualize it. So this diagram we already seen, right? Now we'll just zoom in a little bit and we'll see what exactly happened here, right? So if we see here, starts off with the start node here, right? So if I can just get this marker, yep, okay. So now here we see the initial state is num1 is 5, num2 is 3. This is the starting, right, where we are giving the input. Now here we reach the first node where addition is happening, right? Addition. So we are adding the num1 and num2. We are storing the result in some result, and then this again is going to be present in the state here, right? Now if we scroll down, so we can just, okay, now we reach the second node. So here the second node is basically nothing but the multiply result node, right? So here we basically multiply the sum result which we got here, right? And this is again present the state here, and then we multiply the sum result by 2, and then we again store the result in final result variable, and we again we'll have this variable in the state again, right? So all these things are getting stored in the state, due to which we are able to transfer or use it across various nodes, right? Use this variable across various nodes. So now here we have the end node where we just return the final result, right? Which is after multiplying the sum by 2, right? And this again will be stored in the state, right? And we can just return the state to return the response. So this was the concept about state graph in LangChain, or in LangGraph rather. So in the previous video, we already covered the simple graph. Now we have already covered state graph in this particular video. So in the next video, we'll see another concept from LangGraph, and we'll try to cover the conceptual part and also the coding part for each and every aspect which we will discuss in this playlist, right? So just subscribe the channel if you want to get more content on such topics. Check the playlist here, and subscribe the channel, like the video and share the video with your friends so that this they can benefit from this video, right? And if you want to use this code, so you can just simply go to this git repository. I'll be adding this git repository in the description or in the comment section of this video, and you can straight away get this code from there, and you can experiment with this, right, for your own projects or for your own learning. You can tweak this as per your own requirement, right? So this code will be available in this GitHub repository, which I'm going to put it in the description or in the comment box. So look out in the comment box, right? So this is all for this video. I'll be back soon with the next video on LangGraph in this playlist. Keep looking the playlist, keep watching the videos, share the videos, like the videos if you like the content, and don't forget to subscribe the channel. Thank you.